we've just been introduced to Lewis dot diagrams, and I've just said that they are good for showing atoms. We have looked at using them to show the bonding in ionic compounds, but actually they're really designed to look at the bonding in molecular substances. So the elements, the diatomic elements, etc., and things like methane and that sort of thing. So what I'm going to do is I'm going to put a few up here and show you the process for how I build these. In our books we've got a step-by-step how to do this, so I'm not going to write those steps out again on the board. I'm going to walk you through how to do it. Okay, my way differs slightly from the book, but not much. Okay. So I'm going to start with something really, really simple. I'm going to start with methane, CH4. So the first thing that I'm going to do with this is I'm going to work out how many valence electrons each of those has. So that's my first step. Okay, so carbon has an electron configuration of 2, 4. Therefore, it is going to contribute 4 electrons to this. And there are 4 hydrogens in here, and that's number 1. So clearly its electron configuration must be 1. So it must be 4 times 1. So the total number of electrons that I need to have in this compound is 4 plus 4, 8. Okay. The next thing I'm going to do is I'm going to draw the central atom. How do I know which one's the central atom? Well, it's the one there's only one of. Okay. So usually there'll be one that there is only one of. So there's only one carbon. So I'm going to draw the central atom, and I'm going to do its electron configuration, the way that we learnt just moments before. So I've got carbon with its 4 electrons, 1, 2, 3, 4. Then I'm going to try and stick in the hydrogens afterwards. Okay? So I'm going to change colours for this one. So I'm going to add the other atoms. Hydrogen's structure is this. Hydrogen with 1 electron. That electron could be anywhere. It could be at the top, bottom, left, or right. They're all correct for the Lewis structure for hydrogen atoms. So I'm going to put them in. So I'm going to put a hydrogen there, and so on. Okay? And that is my Lewis dot diagram for methane. I could simplify it. Every time I have 2 electrons paired in between 2 atoms. So here's a pair of electrons in between 2 atoms. Every time I see that, this is a covalent bond. So I can actually represent that as something a little different. I can represent that as a single line. So I could actually redraw this as, which is what we'd normally call a structural formula. So how are these any different to just doing a structural formula? Well, I'm going to do something slightly different for you, and we'll follow the same process and see what happens. I'm going to change one of those hydrogens for chlorine. Okay? Now, there's a bit of a problem here. Well, no, we better start the same process. So we've got carbon has what valency? Or what? How many valence electrons? 4. We have 3 times 1. Why?
Because there's only 3 hydrogens.
Good. And does anyone know how many chlorines it's got?
7.
Brilliant. Okay, so to me it's 14, is that right? Cool. Okay, so I know I've got to have 14 electrons at the end. If I don't, I've made a mistake. Alright, if I don't have 14 electrons in my Lewis dot diagram, I've made a mistake. Now, there's 1 chlorine and there's 1 carbon. That's annoying. Which one do I put in the middle? Any guesses?
An even number.
Yeah, one that's got an even number is often right, but it's not always right. Often nitrogen can go in the middle and it's got a valency of 3, so it's got 5 valence electrons. It's the one with the highest valency, which means which one can make the most number of chemical bonds. The valency of carbon is 4, because it can make 4 chemical bonds. The valency of hydrogen is 1, it can only make 1 chemical bond. The valency of chlorine is 1. Even though it has 7 electrons there, there's only 1 spot. So it can only make 1 chemical bond. So the one with the highest valency goes in the middle if you've got more than one choice. So carbon will go in the middle. Okay. Any questions on how I worked that out? Cool. So again, I'm going to follow exactly the same process. 1, 2, 3, 4. And I'm going to put the hydrogens in. Just going to choose here, here, and here. And I need to put my chlorine in. How many dots do I need to put around chlorine? 7. Okay, so. Oh, that's terrible. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, I'm just going to change it to CL. It's a bit pedantic about these things, making it look good. Okay, so 2, 4, 6, 8, 10, 12, 14 electrons. Yep. If we were to simplify it, the common mistake that is made is this. That this is simplified too. What's wrong with that? That is the structural formula for chloromethane. That is the structural formula, but it's not the Lewis dot diagram for it. How many electrons are in this? 2, 4, 6, 8. It's missing 6 electrons. This is not the simplified Lewis dot diagram. Okay, it needs to have dots or crosses around chlorine. Now it's got 14 electrons. This is a really common mistake. Students forget to put the extra electrons in because they've seen this structural formula before without the dots, so it must be correct. Not when you're doing Lewis dot diagrams. Now, if we ignore the hydrogens, what we're trying to do here is create a magical number around each atom. There are a few exceptions. Hydrogen and boron are the really big exceptions to this. Does anyone know what this magical number is that we're trying to create with numbers of electrons around everything? Have a look around my carbon and count up how many we've got. 8. Remember these electrons in the middle are shared, so we get to use them for chlorine as well. How many has chlorine got? 8. So what's so important about 8?
It's a full valence shell.
Fantastic. Full valence shell, which makes things electrically stable. So we call this, in electron dot diagrams, we call this the octet rule. Okay, so you're trying to do that. The problem is it gets a little bit complicated because it doesn't always just go nicely together like a jigsaw, like with these two. And the example I'm going to show you is oxygen gas. All right, we've got O2. So, oxygen has got how many valence electrons? It's number 8 on the periodic table. 6. Okay, so it's got 16 electrons if there's 2 of them. Sorry, start again. That was terribly done. So it's got 12 electrons if there's 2 of them. Valence electrons, isn't it? 6 in the outer shell for both. Okay, so it's the same atom, so there's no central atom in this one. There's just 2 oxygen atoms. I'm going to use crosses and dots to show you how I'm going to do this. So I'll draw one of them. And I'll go 1, 2, 3, 4, 5, 6. Well, it looks like I might be able to stick some things together here, doesn't it? So I'll put the other oxygen over here. And I'll start here. 1, 2, 3, 4, well, I've got to skip that one, 5, 6. What's wrong with this from what we just said about this, the octet rule? What?
One of the
Okay, so 1, 2, 3, 4, 5, 6, 7 around that one, and 1, 2, 3, 4, 5, 6, 7 around that one. Right, that's a bit of a problem. So, does anyone have any ideas on how we might fix that?
When you put 4
In the middle?
yeah,
So, move that electron into here.
and the one on top as well.
Okay, hang on, let's see. So we'll put that one in there. And that one in the middle as well.
Yeah.
Okay, let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8 around that one. 1, 2, 3, 4, 5, 6, 7, 8 around that one. Perfect. Now, if this is a covalent bond, this is also a special type of covalent bond. This is a single covalent bond with 4 electrons. It's called a double covalent bond. It's a double bond. So the way that I would draw this molecule isn't with a single line, but with a double line. Again, this isn't completed because this only has 2 4 electrons. How many do I need to have according to this?
4 more on each.
4 more on each, so still need this. So what we tend to do is put them as far away from each other as we can, so you can see us simplifying it. Okay, and there is my Lewis dot diagram for oxygen. Okay. One of the things that gets really, really confusing is sometimes you go, and I'll do sulfur dioxide to show you this, hang on, but one of the atoms hasn't contributed or any electrons. Actually, all 12 electrons are involved in the bonding at some stage. These ones don't just stay out here. They end up here at some time, they end up over here at some stage. So this is representing it. I could have done dots and crosses, dots or crosses for all of them, and it still would be correct. All 12 electrons are involved in bonding. All 12. It's just only 4 of them at any one time create the double bond. Okay, does it sort of make sense? They're all involved. That's why we count them at the start, because they're all involved at some stage. And I'll show you what I mean with sulfur dioxide very quickly. I'll just draw it for you. Sulfur, there's only one of it, goes in the middle. The oxygen's go on the outside. Okay? Okay, just trust me, that is the correct diagram for sulfur dioxide. What do you notice about this oxygen here?
It's got a single bond.
It's got a single bond. Has it contributed any of those electrons to that single bond? No. Okay? Yet, the argument is yes, it has, because it's contributed its electrons to the entire electron cloud for the molecule. Okay? So, the fact I've used colours shows you where those electrons came from. This one's clearly contributed 2 to make a double bond. This one doesn't look like it's contributed any. Actually, yes, it has. They've all provided 6 electrons to the entire electron cloud that has then created a double bond and a single bond in what we call a lone pair of electrons. This lone pair becomes really important next week when I'll teach you about shapes of molecules. Okay. So, Lewis dot diagrams for molecules, just a quick recap. First of all, add up the number of valence electrons in total, because then when you do a check at the end, you can make sure they're all there. If they're not, you need to add them somewhere because you've missed them out. Then find your central atom. It is the atom that there's only one of. If that's true of more than one, find the one with the highest valency, which means the number of bonds that it could potentially form. Then slot in the others like a jigsaw puzzle as best you can. If that means that something doesn't obey the Octet Rule, then start making double and maybe even triple bonds by bringing single or double electrons in to make it a double or triple bond. Then double check your Octet Rule and it should be satisfied. You've then got your Lewis structure for a molecule. If there's any electrons left on their own, they are called lone pairs of electrons, so make sure they are paired up, not left miles away from each other. And that, in a nutshell, is how we do Lewis dot diagrams.